This is Josh White with JW Math Tutoring. Today's video is going to cover the 6 hardest problems from the April 2022 ACT Math section, Form Z08. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like back solving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. Moving to the top of the next page, we have problem number 35. And here you have this band thing where they're forming these different formations, in the shape of an L. And, basically they want to find the relationship between how many what number of the formation it is, what number of the formation it is, so like 1, 2, 3, 4, whatever, 5, 6, versus the total number of members in the thing. So there are multiple ways that you could do this one. So one way you could do this one is you could notice, okay, going from 1 to 2, we start with 5 band members, and we end up with 3, 4, 5, 6, 7. So the net increase between between like the first formation and the second one is 2. Okay, that means that like our slope or our rate of change when we increase the formation number by 1 has to be 2. Therefore, the correct answer has to be letter C, because that's the only one that has a 2 essentially in the slope. What would be the slope part, of these line equations, these linear equations. And you could check the same thing for 2 to 3. If you count up 3, 4, 5, 6, 7, 8, 9. You could see it again also increases by 2, and so on and so forth. So that's the easiest way, or the quickest way, just to figure it out. Technically, again, we could also go on the calculator and we could just do the lin-reg function and figure it out that way as well. So for example, we go to the stat menu, we go to edit. Now, our x values are going to be the n's, which is the 1, 2, 3, 4. So notice I've got 1, which corresponds to a y value of 5, the number of band members. And then now I have 2 for n, formation number, corresponding to 7 for the number of band members. And then we go back to the stat menu, and then we go again down to the lin-reg function. We go to calculate. Okay, so we got 2 for the slope, or 2 for m, and we got 3 for the y-interceptor b. So now, excuse me, when we look at the answers, we can clearly see that letter C is the one that matches up, with these values. So that's a second way to do it. A third way you could even do this problem is just take these values of n right here, plug it into the possible answer choices, essentially back solve this. Plug this into the answer choices and see which ones work out. So in other words, take 1, plug it into answer choice A. 1 plus 2 is 3. Does 3 equal 5, the actual number of members? No, cross it out, eliminate it. Then you could check B, it works, so you would keep it. C works, we keep it. D works, keep it. E works, keep it. So like that's probably not a good choice to back solve. You'd probably want to start with like 2 or 3 or 4. But you can go down through and plug them in and see, okay, which one equals 7 when you plug in 2. And the only one that's going to work is, again, going to be letter C. So 3 different ways that you could solve this problem related to linear equations. Problem number 42. And so in this one, I would just pick numbers. Perfect example for picking numbers problem because you have these different letters, different variables, and they give you some conditions on them that like some things must be positive or negative or whatever. So, okay, we know that x and b are positive. So I'm just going to let x equal positive 1. I'm going to let b equal positive 2. So now if I plug those into this equation, okay, I have a times 1 plus 2 equals 0. Or in other words, a plus 2 equals 0. So I get a equals negative 2. So right off the bat, notice that it cannot be h, it cannot be j, it cannot be k, because the value of a I got is negative. Okay? So now the question is a factor of b, or is a multiple of b? So it's going to be, the answer is actually going to be letter F. It's a factor of B. And the reason you could check that is, or the way you could check that, excuse me, is by just picking a different set of numbers. Say x is 2 and b is 5. So now we have 2a plus 5 equals b, excuse me, equals 0. And you get 2a equals negative 5 halves, a equals 2a equals negative 5, a equals negative 5 halves. Okay. So b is 5, and a is negative 5 halves. So typically when we talk about expressions being multiples, or numbers being a multiple of another number, we're only talking about taking the original number and multiplying it by whole numbers. So negative 5 halves is not a multiple of b because there's no whole number, there's no integer we can multiply positive 5 by to make negative 5 halves. Instead, it's going to end up being a factor of b because technically you can take negative 5 halves and you can divide it into 5. And then it's just going to come out to be basically negative 2. So therefore, it would be a factor of it, and the correct answer is just going to be letter F. The page, number 46. So this is an interesting problem because you have basically a triangle that you're given. It's 3 vertices, and then it goes through a translation with both a horizontal and vertical component, and then they want to know where the vertices of the new triangle lie, basically where the image lies. So first thing I would do is I would start with, start with each of the points. So I'm just going to jot them down. 3, 1, negative 1, 1. Okay, and then we're going to go through the translations. So again, remember we're just going to do x plus 5 and y minus 2. So we go ahead with point A, we add 5 to it, we get 2, and then for the y value, 3 minus 2 just gives us 1. And then looking at, so notice first of all right away, this is going to be in quadrant 1. So right off the bat, we can get rid of this, we can get rid of this, and we can get rid of this. So we're down to 2 answer choices right away. Also notice now for point B, again, this is A, this is B, this is C. For point B, we don't need to spend time checking the x value. We already know where the x value is going to be. I mean, we could just write it as 2, but just whatever, ignore it. Y value, start at 1, we subtract 2 from it, we go down 2, that puts us at negative 1. where is this point, 2, -1? Well, right 2, down 1, it's going to be down here in quadrant 4. So therefore, we have our answer. It's just going to be letter J, quadrants 1 and 4 only. And notice you don't even need to check point C. Although, if you started with point C, just to show you, you would end up at 4 for the x value, and you would end up at -1. So you would end up in quadrant 4 as well. But the point is, you don't need to spend time doing that. Just do A. You can just do A and just do B, and then that's it. You have your answer. Move on to the next question. A picture here of an ellipse with a rhombus inside of it. It applies to the next 3 problems. So starting with problem number 49, it wants to know the area of the shaded region. So whenever you have a shaded region, we're going to follow the general approach of, area of the large minus area of the small. Or in this case, the area of the small is really like the area of the white part. So the area of the large in this is just going to be the area of the entire ellipse. Now, they give you the formula for the area of an ellipse here. Okay, so it's pi times A times B. A and B are half the lengths of the major and minor axes. So the major axis is just the total distance from in the longest direction. So basically the major axis is like this whole line segment right here from A to C. So 8 is just going to be half of that. So we could plug in that for A, and then the minor axis is the whole line segment here from B to D. But again, we just want, for B, we just want half of that. So in that case, this is just going to be 6. So the area of the ellipse is just going to be 48 pi. So for our overall expression, it's going to be 48 pi minus something. So just right off the bat, we can eliminate this, we can eliminate this, and we can eliminate this. Now, for the area of the rhombus, there are technically 2 different ways that you could do it. One way that you could do it is you could go ahead. Well, actually, I guess there's really technically like 3 different ways you could do it. But one way you could do it is you could notice that it is 4 different congruent triangles, basically each of which are like 6 by 8. So if you find the area of one triangle, 1/2 base times height, that's just going to be 1/2 times 6 times 8. So 6 times 8 is 48. Half of that is 24. Again, then we would take that 24 and multiply it by 4 to account for all 4 triangles, and that would give us 96 as the area of the white part. So now for the overall answer, we're just going to subtract 48 pi minus 96. Area of the entire ellipse minus area of the rhombus. So the correct answer is going to be letter D. Now, an alternate way that you could get the area of the rhombus is you could use the formula where it is equal to, and this is specific to a rhombus, but you could use 1/2 times the diagonal 1 times diagonal 2. So the 2 diagonals are pictured here. The longer one is going to be 16. It's technically the equivalent to the major axis. The shorter one would be 12. So then, okay, 1/2 of 16, if you just simplify it, is 8, and then 8 times 12 is 96. So we get the same value. It's just an alternate way to do the problem. It's a shortcut formula, but if you don't have it memorized, it's totally understandable. Then you just, look at the individual triangles and find their areas and then just add them up. Problem number 55 at the bottom of the page. Here you have some problem dealing with parking spaces. So you're going to have parking spaces 1 through 150, blah, blah, blah. And it wants to know how many total digits will be painted for all 150 parking spaces. So here's how I would think about this one. Okay, for space 1 through 9, you're going to have a total of 9 digits because they're each one digit. Okay, then let's look at 10 through 99, all the two-digit space numbers. So there are two digits for each space, but then the question is how many actual spaces are there? So the answer is going to be 90. Now, if you subtract them, technically you get 89, but you have to remember that like when you subtract them like that, it doesn't count in like space actual space 10. So there's multiple ways you could figure this out. I mean, you could think, okay, 1 to 100, there's 100 numbers, and then take away 1 through 9, so that, so we have 100 to start with, we take away 9, we're down to 91, and then you also take away 100. So that's another way to just reason out that it's 90. Therefore, the total number of digits for those spaces will be 180. And then for the three-digit spaces, 100 through 150, well, they're each going to have three digits. And how many of them are there? Technically, there are going to be 51 because you're starting at essentially say like 0 and then it's 101 up through 150. So it's 150, it's 50 and then say plus 1 if you add in the 0 for 100. So you go ahead, you just multiply these together, you're going to get 153. And now we just add 153 plus 180 plus 9, and the total is going to come out to 342. Therefore, total number of digits that are going to be painted is 342 digits. Here, the strategy that I would use is picking numbers. So it says they tell you x is an odd integer greater than 1, and they tell you that b is equal to whatever x minus 1, and then they give you some equation, and blah, blah, which, you have to figure out what the value of a is. Okay. So what I'm going to do is I am going to pick 3 for x, odd integer greater than 1. Basically, it's the smallest option we have. And then b will have to be equal to 2 because b is just 1 less than x. All right, so now that we know that, excuse me, now we'll go to the equation here. So we have log base 2 of a is equal to 3. So now if we just rearrange this, put it into exponential form, 2 to the third is going to equal a. Or in other words, a is going to equal just 8, because that's what 2 to the third is. So now when you look at our answer choices, okay, we can eliminate a because 8 is not odd. We can eliminate b. We can eliminate c. We can eliminate d. And just by process of elimination, we are down to e right here. Notice that basically it's always going, and the reason why it works out like this, just to go to a little bit of the theory behind it. So if x is an odd number, whatever that is, whether it's 3, 5, 7, 9, 11, 13, whatever number you pick, b is always going to be an even number. So when they specify that x is odd, because b is 1 less than it, b is always going to be even. So when you take this log thing and then you just rewrite it in exponential form, you basically have an even number raised to an odd power, although that technically doesn't matter, and that's what a is going to equal. So any even number, multiplied by itself or raised to any power is always going to remain even because, if it's even, it divides by 2, and therefore, when you just multiply it by itself, the factors of 2 are still going to remain in the final answer. So that's kind of the theory behind it, but the answer is just letter E. And again, I use the strategy of just picking numbers to figure it out. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.